All right, so let's look at these examples. And this first one says, I give you 4 different normal curves. And I know they're normal because they're shaped. They're all bell-shaped, and they're all symmetric or unimodal. And so notice this in this particular curve that 3 of these curves have the exact same mean, because I can tell what the mean is because it's the center of the curve. What makes these 3 different curves different, though, are their standard deviations, because they have different squeezes or different tightness throughout them. Now, it says, first problem, it says, what is the mean of each curve? And again, you have 3 of them that have the exact same curve. They have the exact same mean. B, C, and D all are located at the value of 0, and A is located at the value of -2. That's what makes A different from B, C, and D. So the first one is we know that the mean of A, which we'll call mu of A, equals -2, sitting here. It's the middle of the curve. The mean of B, C, and D are all the same values. So the mean of B is equal to the mean of C, which is equal to the mean of D, and they're all equal to 0. Which has the smallest standard deviation and why? So in order to answer this problem, we want to think about again, what is the standard deviation? And remember, the word standard just means average. And your deviation is how far away from average you are. So if you want a small standard deviation, you want the value to be very close to the average. Well, we know the average in a normal curve is at the middle. Therefore, when we're looking at this, if we're talking about a smaller standard deviation, we want the values to be very close to the mean or very tight, such as in B. The values in the curve of D are very spread out. It has a larger standard deviation. So the smallest standard deviation is sigma B, because it is the curve that has the tightest. And so sigma B, and then the next curve with the smallest standard deviation would be sigma A, and then followed by sigma C, and the largest is sigma D. And so what you're looking at, you're going from tightest, if you want small, or narrowest, to the widest, if you want a large standard deviation. Now let's look at example 2. Example 2 first asks, what is the mean of this curve? Well, we saw from the other one, to find the mean of a curve, you look at the center of the curve. So the mean here, the mean of this curve is just mu is equal to 0. The next question is, what is the approximate standard deviation of the curve? The first keyword is the word approximate. So we're not going to get the exact value, but we can get very close to it by using what we know about normal curves. Now, we know that the mean should occur, the standard deviation should occur somewhere right here. Here's where the first one should occur at, right? And that's because that's what we call, this is what we call inflection points, where it starts to fall. So that's where one of them should occur at. So when I look at this then, in order to find this value, here's what I need to know. I need to remember that there are 6 standard deviations underneath this curve. And because there's 6 standard deviations underneath the curve, the other thing I can find from this information is the range from the smallest value to the largest value. And that range is just 200. And again, that's -100 to 0 is 100, 0 to another 100 is 200. So I know that the range is 200. I can divide that by the number of standard deviations I have underneath the curve, which is 6 sigma. And that gives me the value of 1 sigma. So take that, divide it by 6, and you get 1 sigma is equal to 33.3. And that's about where it's located, 33.5. And I can do that again because I know that there are 6 standard deviations in the curve. Similarly, I could do it from here to here, where there are 3 sigma under the curve, so that equal to 100. Divide this by 3, and I get sigma is equal to 33.3.